minus 5x minus 6. And they want us to determine whether f is one are factors. Well, we'll do the x plus 1 because that is. Okay, so here we go. For this particular problem, and for all problems like this, it's Elena, and you're here. Good for you. I marked you in. How about Angela? Did you make it in?
Yes, sir, I'm here.
All right, I got you in. All right, so here's the problem. You have x cubed plus, and this is on the test, by the way. You got to get this right. 2x squared minus 5x minus 6. And all of this is divided by x plus 1. Now, in division of polynomials, you have to have every position accounted for. So notice you have a 3 here. It's a 3. Writing pretty good here. 3, 2, and this is technically 1 and a 6. And what you want to do is shrink it. So you're going to multiply this number here, or this variable, by something that'll make it a cube. And we're going to do it by x squared. You take x squared times x, you get x cubed. You take x squared plus times 1, you get plus an x squared. Now, the rule is you change signs. You subtract it. That makes these cancel. That gives you 1x squared minus 5x minus 6. Now, in order to get x squared, we're going to multiply this by a positive x. To do that, you get x squared plus x. We change signs. So this becomes gone. This becomes a minus 6x. Because if you have 5x and you lose another x, you minus 6x. You bring down this minus 6. You have a minus 6 here. What do you got to multiply x by to get minus 6? It's a minus 6. But the problem is you want to then, after you do that, you change the sign. Remember, all you got to change signs, and then that makes it 0. So if there's no remainder, this is a 0 down here. That means x squared plus x minus 6 divided by x plus 1 is a factor. So that means x plus 1 goes into this evenly. Goes into it evenly. So that means negative 1 is a 0. That's what it means. That's critical. You're doing all this simply to find this number right here, to find the 0. Now, we're going to go to the next one. We're not through, we're just, but that's very important what we just did. Now, if you look at the second one, they take x squared plus 5x plus 10 and they divide it by x cubed plus 2x squared minus 5x minus 6 divided by x minus 3. Now, the first one we did was x plus 1. And when they divide it by x minus 3, they get a remainder of 24. That means it's not a factor. I mean, you do not get a 0. The next page. The remainder theorem. Excuse me. I'm going to give you this in the short version. Thank you. I'm going to give you the short version, and I'm going to give you the regular version of this. The short version will make it make sense. The long version doesn't make sense until, I mean, it will eventually. Okay, so now, let's do this. Let's say we take 7 and divide it by 2. We know it goes in 3 times with a remainder of 1. So if we take a polynomial and we divide it by something and we have a remainder, the same thing is going to work with the polynomial. So here's what that now should mean to you. They give us the problem, x 2x cubed plus 7x squared minus 5 divided by x 3. Now they're using synthetic division. Now, have you guys had synthetic division? You have or haven't? You have?
Yes.
We have on the test.
Okay, so look, when they divided it by -3 and with 4 left over, so that means if you put -3 in the equation, if you put it in there, you're going to get 4 as a remainder. Now, they don't show you this yet, but put it in there. If you take a -3 and you cube it, you get a -27. If you multiply that by 2, you get a -54. If you put a -3 in for x squared, you get 9, and 9 times 7 is 63. That's positive. Now notice that we have 2 numbers so far. A -54 is 63, and then a -5. If we add those all up, if you take the -54 and the -5, you get a -59. You add it to 63, you have a remainder of, what's your remainder?
Four.
Yeah, of course. Again, if you put the -3 into this equation that you divided by, into the original equation, you're going to end up with 4.
So it's easier to substitute instead of synthetic?
No, it's just another thing to know, Lizette. It's synthetic division is important. It's just to note that that it works. That it's there's more to it than just the division. Now, number 3 is just a long one, and they make it very complicated. They want you to find f of 10. So now they're leading you up to how to do this. So that means you got to put 10 in the equation. So 10 to the 5th power. I mean, this is ridiculous. Who would want to do this in a learning process? But that's what they do. And the remainder is 170,802. Of course, f of 10 is going to give you that. I would have done this easier. The one I did was easier. Number 4. It works like any other problem. Remember, we did 7 divided by 2. We got 3 with a remainder of 1. Well, if you put it in there, you're going to get the same thing. 3 times 2 is 6. Add 1, you get 7. Let's see if we got it. Okay, so number 4. Determine whether 5 is a 0. You can do it this way, and Lizette, then you can do it your way then too. So if you put 5 into the equation, 5 times 5 is 25, times 5 is 125, times 5 again. Let's see, what is that? 25 times 5 again, 625. And if you subtract 25 times 26, 26, you should be doing this in a calculator. 25 times 26, you're going to get 600. And then if you hey, you get a 0. So look, if you take the number 5 and put it in for x, you're going to get 625. You put 5 in for the x squared, you get 25 times the negative 26. It gives you a minus 600. Let's see, minus 650. Actually. And if you add the 25, you get back to 0. Pretty cool. Determine whether I is a 0 of x. Now, this is a little bit more complicated. So look, we're going to divide by I. And the rule is that if I is a 0, then negative I is also. It's always the same. So you bring down 1, you take I times 1, you get I. Negative 3 times, and add it to I, you get a negative 3 plus I. Multiply that by I again, so you get a negative 3I, and I times I is I squared, which is minus 1. Add them up, you get a negative 3I. A negative 3I times I gives you a positive 3. Negative 3 and 3 gives you 0. So number 5 is just I don't know, they just try to make it a little bit more challenging by throwing in an I, but you should know how to multiply that. But the most important rule is if I is a factor, then a negative I must be as well. That's the rule. Let's go to the next one. Okay. It says now, let f of x equal x cubed minus 3 squared minus 6x, and let f of x, and solve the equation f of x equals 0. So look, the solution is, they say, try negative 1. If you read the second sentence, it says, let's try x plus 1 or x equals negative 1. That came out of their head. They're just saying to do that. And of course, they get a 10 remainder, so it doesn't work. So then they say, okay, if negative 1 didn't work, let's try 1, which really means x minus 1. It's always the opposite. And it works. So 1 is the factor, which means you have x squared minus 2x minus 8 left over. You can see they have it right there in this line right here, right below. It says f of x equals x minus 1. Remember, when you divide by 1, it's really x minus 1 because it what makes it 0. And then they can factor the x squared minus 2x minus 8, which factors to x minus 4 and x plus 2. So the three zeros are 1, 4, and negative 2. Again, the equation was x cubed minus 3x squared minus 6x plus 8. We found out that 1 was a factor, they showed it. Doing the math portion of using FOIL, we found x minus 4 and x plus 2, which would mean 4 and negative 2 are factors. But let's check. I don't believe it. Let's say we don't believe it. So I'm going to give you some practice on this with me. I want you to see it done. So again, we have x cubed minus 3x squared minus 6x plus 8. And we're saying that either 4 or -2 are zeros. Using synthetic division, this brings us down to 1, -3, -6, and 8. So let's try -2. Bring down our 1, -2 times 1 is a -2. Add them, get -5. -2 times a -5 gives you 10. 10 and -6 gives you a -4. A negative times a negative gives you a positive. So we have to take the opposite of that, which would be a 2. Let's see if that works. 2. Something didn't work right there. Did we copy it down right? 4. Oh, my bad. Oh my goodness. This is a positive 4. This is not. This is supposed to be a -2. So we said it was a -2. And a negative times this gives you a -8, which gives you 0. I probably confused you. Let me do it again. I don't want to confuse you. Just put that. So we had a 1, 2, -5, and a 6. And we divide by, we said our zeros were -2. So we're going to bring down a 1. This times this gives you -2. Oops. I'm doing that right? Let's see if it's 0. 5 didn't come out right at all. That's worse. Must have wrote it down wrong. X. I got it. And it should be 1, 1, -3, my bad. -6 and 8. And then I put a -2 over here, my bad. Bring down our 1. And that gives us a -2. Gives us a -5. We add them. Gives us a +10. That gives us a +4. Gives us a -8. And that's a 0. Now that means then you have x squared minus 5x plus 4. And that factors to x minus
I would say
be
4 times -1. No.
this should also be a factor. X squared minus 5x. This is doing something wrong. It should be wrong.
-4 times -1? No, because that would give you a +5.
Perfect. That's perfect. That's what it is. And that gives you the other 4 and the other 1. Perfect. That's exactly right. Using plus. So I gave you the -2, the 4, and the 1. That's really good. Is that Lizette?
Yes.
That's cool. All right. Let's go back now and look further. Let's see if there's anything else in this. Spent a lot of time on this chapter about the zeros and the remainder. See if there's anything else we want to do in this chapter that would be helpful. Do we know what page 8.6 is on? Anyone?
Yes.
538.
538. That's right.
538 is the next one.
Yes.
That was a good chapter. I liked it. It was fun. Learning. You guys are a good group. think we got there. Can you guys see it now?
Yes, we can.
Okay. So we won't need to do many of these, but we need to be clear how to do them. Number one is considered a level 5 problem. I don't know why they start out with it, but I think they feel like you should know how to do it. On the exam, you'll get one like this, nothing any more complicated. So we have to read what it says here. It says that we have a polynomial of a degree of 3. That means it's a cube. It has the zeros 1, 3i, and negative 3i. So what does that mean? If it's 1, if you look at the solution, you have x minus 1, because in order to get 1, you have to have x minus 1. If 3i is one of the solutions, you have to have x minus 3i. Of course, as I shared with you earlier, if you have an imaginary number positive, you have it negative and vice versa. So now you have all the parts of the puzzle there. You have x minus 1, x minus 3, and x plus 3i. And they want you to find the polynomial of degree 3 that meets these criteria of having these zeros. The thing you don't know about is a to the n. You don't know what the leading coefficient is. So they say, well, let's just try to make it 1. If it's 1, you make it disappear. Now, later on, they're going to have you do it a little differently. So if it's 1, we don't use it. So now we're going to take the two last parts and multiply them. X times x gives you the x squared. The middle terms drop out because one is negative 3ix, the other one's a positive 3ix. Now you have 3i times 3i, and it's a negative. And 3i times 3 gives you a negative 9i, but a negative is plus 9. So now you have x minus 1 times x squared plus 9. Well, x, if you multiply that out, so you easily can see how you get the x minus 1 and the x squared plus 9. Now let's do that and see if we can get the last. So we have x minus 1 in parentheses times x squared plus 9. You take this times this for x cubed. You take this times this and you get 9x. Take this times this, you get a minus x squared. And this times this, you get a minus 9. When you multiply that all or add it up, you get x cubed minus x squared. Now let's see if that's what they get. Hoping that's right. See if I can get this. Let me look at one more time. Minus x squared minus 9. Deanna, you're here.
Yes, sir. I'm here.
Gotcha. So let's go back now and see. Nope. For some reason or another, we did it wrong. So let's do it again. We gotta get it right. I don't understand what do there. Go here. And we have x minus 1 times x squared plus 9. We take this times this, we get x cubed. This times this gives you a plus 9x. Make a mistake. This times this gives you minus x squared. Yeah, and there it is. And this times this gives you minus 9. So yeah, we have x cubed. Forgot the x minus x squared plus 9x minus 9. And that's the solution. And that's simply by multiplying it. We proved it works. I was just stubborn and wanted to do it. Just make sure that it works out right. Now, number 2, this is a degree of 5. If -1 is a 0, so that gives you x plus 1. But it has a multiplicity of 3, so it's a cube, x plus 1, 3 cubed. I hope you understand what they mean there. It says find the polynomial function of degree 5. That means it has to have x to the 5th power. With -1 as a 0, that means you have to have x plus 1. You can see it right down here. The second line, with a degree of 3 or multiplicity of 3. So that. This is 4 as a 0, so that means you have to have x minus 4 and 0. So I mean, that's easy. In the second line is x plus 1 cubed, x minus 4 times x, and life is good. Does that make sense for number 2? That's probably the easiest
Yes.
one. Now, the only way they can get harder is if they want you to find the a to the n. See if we can do one of those, if that'll come up. Let's see what we do next. Rational thing is 3 zeros. Okay, we know how to find zeros. We know if it has a -2 plus 5i, that's a -5i. That's a -2 plus 2i, and then you have 1, 3. So we know all that. The conjugates, we know what those are. You just write the opposites. So again, the conjugate means the opposite. So if you have, let's see which one's next. It might be interesting. Square 3 at 1 minus 1. So look, on this particular problem, number 4, find the polynomial function of the lowest degree with rational coefficients, and they have a square root of 3, 1 plus I. So if you have a square root of 3, you have 1 plus I, you know you have to 1 minus I, and that's all you have to do. You just have to keep remembering that if you have an I, you have to have a negative I. You'll never see a problem like this in our homework or text. I'm trying to find one that you read, that you should know about. The other ones are just, I mean, on a test question, this is what you'll see. And that's what all they're trying to get you to understand. And I'll show it to you here so we can get this thing going. If on the test, if they say something like this, 3 is a 0, 2i is a 0, and 4 is a 0. Give me the factors that you have. Anybody give me any of the factors? Those are all zeros. Well, you have x minus 3. Away from that. From this, what would you have?
-4. X minus 4.
Okay. So you have 2i coming from this. What else would you have?
-2i.
Exactly. That's all they're trying to get you to understand. Now, when they talk about the conjugate, like if you have 2 minus I, the conjugate would mean, if this is a factor, you have 2 plus I. That's what they're trying to tell you. You see it. Let's see what else. Make this better. Okay, well, we just, Lizette explained that if we -1, if we find the 0, we can, then obviously, there could be others. what they did here, what they're telling you here in this problem number 5. Find the rational zeros and then the other zeros. So what, using some of the rules, you're guessing, as you can see here, that third line there, second line, all those numbers, including the fractions, starting out 1, -1, 2, -2, 4, -4, those are all guesses. And what they did is they took the numerator over the denominator to get the possibilities. Now, what they did is next, they tried number 1, that was a no-bueno, because you got -2. So if you try 1 and it doesn't work, then you try -1, and it worked. So once that works, we know we have x plus 1. Now, that means this 3 stands for the remainder, 3x cubed minus 14x squared, 14x minus 4. So we got to try something else. So the next page is going to say, and usually they do 2's or -2's, until they can get it down to a square, because then you can use the quad if you need to. But at a cube, let's see what happens. Or you could group it. Let's see what they say. So we found 1, okay? Now they're going to try it all over again for the cube. So that didn't work. They tried a fraction. You never get that from me. And then they got what's left over is x squared minus 4x plus 2. Now x squared plus 4x minus 4x plus 2 doesn't work. So use the quadratic equation. They plugged it in and they got the other ones. 2 plus the square root of 2 minus the square root of 2. This is, yeah, you can do this problem. And technically it's not hard, except for you had the fractional part. Again, the number 6 are going to do the same thing. You won't get fractional ones. And we are certainly going to go to the 5th power. You can all start using computers to do these. I mean, it's something that I could do that is not really made for you to do. I mean, you kind of, but not really. I meant to say something that they could make me do it. Descartes' rules of signs. You guys already had that, right? Or did you?
Yes.
Yeah, you know that if you have the number of sign changes tells you the number of positive zeros. You get 4 sign changes, then there are 4 possible zeros. Then you put the negative number in there, and if you know how many sign changes there, so you've had all this in the term of variation. So, earlier in the book they did a better job of showing it. So from this one is 1, 2. So they have 3. The number of variations of sign changes say is went for positive, negative, and negative to positive. So the number of possible zeros are 2 and 0. That's all they're trying to. It's to help you guess the zeros. But in the real world, I always guess 1, -1, 2, or -2. Let's see here. Getting some number of sign changes. Look, I'm not going to waste your time, you guys, anymore, because you can see what they are. You had this part on the test. Positive, negative sign changes. The last part here. And I think we're just about done. I don't know if you heard the announcement that they said that here's the sign change again for them, and so on. I'm not going to. That's it for the chapter. They announced that the colleges will not have classes again as they had planned to on campus at all. I don't know how that's going to work. They also announced that enrollment has gone not up but down. People are not wanting to take these classes like this online very much. Some of the teachers just don't. They don't even come on. They don't even talk to the students. I don't know if you know that. They just put stuff online. You're supposed to do it, and if you don't do it, boom. I don't know how. It's kind of tough. But anyway, I'd say hasta la vista to you guys. Hasta la vista.
Thank you, Dr. Wickman. Happy Veterans Day.
Yeah, thank you. Any questions, you guys?
No, happy
No.
Veterans Day. Thank you.
Here, Dr. Wickman. Can you mark me in?
See you guys. Have a nice night.